Mass of the Sun. We have a table below, and that shows the orbital data of 4 of the Sun's planets. First of all, which quantity should be graphed so we have a straight line whose slope can be used to find the Sun's mass? B. Complete the table by calculating those 2 quantities and label the top of each column and show the units. Again, that's a point on the AP exam that you do not want to give up. Plot a graph, label the axes and values. Again, another point. And then finally, find the mass of the Sun from the graph. Which quantities should be graphed in order to have a straight line whose slope can be used to find the Sun's mass? Well, we start with our expression of period, or orbital period versus orbital radius, because that's what we're given here, and we divide through both sides by r cubed. So we have t cubed over r cubed is equal to this number right here. That's a constant, okay? So if we can get that to be the slope of a line, that's super. So if you look at t squared over r cubed, if we plotted it like this, so where's r cubed? R cubed is here. Here's t squared. Well, what does that look like? That looks like y over x, rise over run. So since it's equal to a constant, we'll get a straight line. So t squared over r cubed would be the slope of that line. And see, we have slope there. So the slope is 4 pi squared over gm, where m is the mass of the Sun. Now we want to find the mass of the Sun. So we'll multiply both sides of this expression by the mass of the Sun and divide through by the slope. So the mass of the Sun will be 4 pi squared divided by the universal gravitational constant times the slope of that straight line. Complete the table by calculating those 2 quantities. Well, we said we wanted t squared over here, so that's going to be this column, and we'll have r cubed over here. And notice we kept the order. We had radius period, so now we have radius cubed period squared. And this is very key. You get a point for labeling this properly, and make sure when you do orbital radius cubed, you put cubic meters, meters cubed. For orbital period squared, you put seconds squared. And then it's just a calculator exercise to put all those numbers in. And now you plot your graph. What's handy on this is always put a title, even if they don't specifically ask you for one. This is also key over here. And notice we're going to plot t squared, but I don't want to keep writing 10 to the 14th, so I can just put it in my parentheses there, and then just plot 12, 10, etc. And the same thing with r cubed, and make sure you show meters cubed there. And then you draw your straight line. You do your best to connect it up. You draw a straight line fit, or you can actually put it on your calculator if you have a graphing calculator. The problem is the exam will ask you to actually plot the points and then draw the line. So you should have a straight edge with you during the exam, like a ruler, something like that. If they give you an area to plot, and let me just go ahead and erase all this, you do not want to set your x and y axes so when you plot the points it takes up that much area. You lose credit for that. They want your graph to take up most of the area that they give you. So again, if your graph comes out to be like this, you have to go revisit your values for x and y. You want to take up as much of the graph as you can. Now find the mass of the Sun from the graph. Well, we showed this a few slides back, so make sure you show this calculation somewhere, probably here in point D, or you could have shown it in A. And if you show it in part A, just say here when you're answering D, please see answer to part A, so you don't have to duplicate all that. Now here's the key, right here. Be sure you find the slope of the best fit line from points on the line and not from the plotted data points. So let's just go back a slide, and let me erase this. Do not just take this point and this point, even if they are on the line. In this case they are, but we got lucky. Don't use that to find the slope, because the whole point of a best fit line is to average out all your values and come up with the best fit. It's its name. So what you try and do is find places where they intersect the graph paper. So there's one, and this isn't really that great. There's not another one, is there? But find another point somewhere. Let's say this point was a good one. And circle it. Go ahead and circle it and put a note saying used for slope. Because you will lose points if you just use some of the data points that you plotted. And circle it so the grader knows exactly what you've done. So when you do that, you put the slope in, and be sure you pay attention to the exponents, and then you find the mass of the sun.